Hey everyone, it's time for another mock interview. Welcome back. Let's get started. So, evaluate reverse Polish notation. Evaluate the value of an arithmetic expression in reverse Polish notation. Valid operators are plus, minus, multiply, and divide. Each operand may be an integer or another expression. So some examples is 1 plus 3 multiply. That becomes 2, 1, and then we plus those together. Then we get the result of this, and 3, and we multiply. I don't know. So basically, if you don't know what reverse Polish notation is, it's basically there's no precedence. So like you don't multiply first and then plus, it's just whatever you see first you do. So you just take the first two, then you apply this, then you take that result and the next number and you apply the next one. I would say that, at least if I was doing the interview, I'd say that I've already done something similar like this, because I got, basically, this was part of one of our homework assignments. But yeah, so that's kind of straightforward, right? So you just go through tokens until you have your final result. So what are the different ways we can solve this? We can use recursion and then take out the first two or the first three, and then get that result, and then put that back at the front, and then we keep doing that until there's only one thing left in our tokens vector. But yeah, we can do that recursively, or we can just do that in a while loop, right? So while tokens dot size is greater than 1, and at this point I'll also just verify with the interviewer really quick, like, will the tokens always be valid? Would it ever be empty? Will it always have a number, and then operand, and then, oh wait, so what's going on here? So in the second line, 4 is ignored, and we do 13, 5, and divide first. And then after that, then we take this and we apply 4 to that. Interesting. So maybe I'm probably remembering it wrong then. We can't just go from the left. We can't just take the first 3. I'm guessing we go all the way until we find our first operand, and then we take the ones before it and we combine those together, and then we continue. Now there is the brute force way of just looping through the array each time until we hit an operand, and then taking the two values before that and evaluating them, and then putting those values back in. But then that would mean that every iteration of the while loop, we'd have to find the next operator. Instead, what we could do is, because we know that once we find the operator, the next operator is going to be after that index. It's not going to be before. So we can just have one index and just keep track of that. That could work. One thing I have to note though is that when I combine items, the index will have to be subtracted. Yeah, the index will have to be subtracted by 2, because these will disappear. Okay, yeah, that seems like a good algorithm to start out with. So I'll declare an integer that's called operand index, so op index for short. Just set that equal to 0. Although if we wanted to, we could set it equal to 2, because that's the first possible position that the operand can be at, or the operand. But I'll just set it to 0 just for simplicity's sake. So while we can call it is op. So while the tokens at op index isn't an operator, op index plus plus. So we have to write this really quickly. It will return a Boolean value that signifies whether it's operator. It's op, and it takes in a string. We'll call that s, and then just return if s is equal to plus, or s is equal to minus, or s is equal to multiply, or if s is equals to divide. Okay, so we have that. So now this will tell us, this will keep incrementing until op at index finally is an operator. After that, we have to calculate it. So we can do int num equal int result equal calculate and we want to pass in tokens at op index. So the first one, so -1, -2, and then the second number, which is at op index -1, and then we want to pass in the operator, so it's tokens op index. So now we have to write that. This is int calc. How does it take? Well, it takes in 3 strings. String number 1, string number 2, and string operand. Okay. So I need some ice cream. Okay. So first of all, we should probably convert these strings to numbers. So int num1 equals to I think it's a2I or something. S2I. S2I. Okay. S2I number 1. We do the same thing for number 2. Okay, so now these two numbers are actually numbers, and we do a switch statement so that we can like go through we could perform the right operation. So operand case one. So if it's a plus, then return num1 plus num2. Else, if it's a minus, then multiply return num1 times num2. And if it's a divide, then return num1 divided by num2. Okay. So now that we have this function, that this will calculate the result, and now we have to, I guess, take out take out the first three numbers and then put in the token, right? So how do I do that? Tokens dot tokens dot begin, I think, plus op index. Okay, so this will erase the one of the operator. Then we want to erase the one right before the operator, and then so we still need to put the result, right? So we just, instead of erasing the first number and then inserting the result there, we just replace the actual string. So what I mean by that is tokens at op index minus 2 will equal to string result. And after that, we have to set op index to be op index minus 2, right? So it's 2. Okay, and then at the very end of this, when tokens.size is now equal to 1, that is our final result. So we just return tokens at 0, and we convert this to an integer. So we do s2i. Okay, at this point I would say, okay, so this is my rough draft. Now I'll just walk you through my algorithm again. So we're given a vector of strings, and they're either numbers or operators or operands, and we keep track of the operator index because that way we know where we left off, and we use this index to find the next operand. So when token size is equal to 1, that's when we know that we solved the whole thing, and we just return it down here. Until then, we want to process all the operands. So basically, we go through this while loop, up and down, and we just keep going until we find the next operand. After we find the index of the next operand, we then calculate the previous two numbers using that operand with this function, and we get a result. After that, we have to erase. After this, we have to erase the operand, the second number, and we replace the first number with the result. And then after that, we have to update the operator index because we just deleted two numbers. So yeah, I'm gonna run this. Hopefully it works. This one was more simple than some of the ones I did earlier. But I'm definitely thinking if there is a way to solve this without updating and deleting the tokens vector. But we'll submit the solution and see what happens. Pending. What? Switch quantity, not an integer? Oh, what? I think my roommates are arguing about who's doing the dishes. Okay, so I guess in C++ you can't switch strings. So I guess I'll have to resort to a simple if and else. If upper Okay, let's see if that works. Line 22. What? Expected after class definition. Oh my gosh, what is happening? Calculate. Oh, why is there? Alright, so there's an extra bracket. Okay. So basically, if the time limit exceeds, that means that my solution is good, like it's correct, but it's too inefficient. This is crazy. Alright, so let's see how we can optimize this, and I have 19 more minutes. Okay, so wall tokens, so we keep doing that, and then find the operand. Maybe it's because we're erasing stuff. That's what I was talking about. Maybe we can not need to erase things. Okay, so this might be, I'm pretty sure they'll allow this on the interview, but this is definitely not something I would have come up with on my own. But I remember in my assignment, we used a stack. And basically we just kept pushing onto the stack, and then when we saw operator, we would execute the first 3 and then put that result onto the stack. And now that I'm thinking about that, that makes a lot of sense. That way we don't have to modify tokens. Wow, that's actually pretty kind of proud of myself there, but I'm still not sure if that will work because it seems faster, but I might run out of space if there's a space limit or whatever. But yeah, so I'm just going to delete all my hard work and I'll make a stack string, call that S. Then so how do I want to do this? I definitely want to go through all the tokens, and then I'll go through all the tokens, and every time I see an operator, I perform that pop3 calculate thing I was talking about, and then it should just work out, because at the very end, it's always going to end with the operator, right, or operand. So I'll hit the last operand, I'll do my calculation, and then I'll be good. Okay, so for int I equal to 0 while I is less than tokens dot size I plus plus. Then if it's an operator, then do something else. We just want to push the tokens onto there. And then at the very end of this, the stack should only have one item. So I don't know any of the stack methods. I guess we could just do string ret equal to s dot top, and then wait, was it top or was it peak? Okay, it's top. Okay, so s dot top, we get the ret, and then we return so we're returning a string, so s2i. Okay, and then now we have to fill this out. So basically we have to pop out the first three. Actually the first two, because we haven't pushed in the operator yet. So string num I'm also going to, because so right now what I'm doing is I'm taking a string, I'm converting it into an integer, doing my calculations, and then turning it back into a string, right? I might as well just have them all be ints to begin with. So over here, instead of just pushing the string onto the stack, I would push the integer, which means that the stack will now just be a stack of ints. And then so if that's the case, then int num. Okay, so the first one that we pop out will be number 2. So s dot. Okay, so at this point I'm going to pop, right? But I don't know if popping will return anything for me. Okay, so it removes the latest element and returns nothing. So that means I have to do s.top and then s.pop. And then I have to do the same thing for num1. Cool, now we have num1 and num2. We already wrote our handy calc function, and that returns us the result, which will then push back onto the stack. And tokens. Did you get all of that? So this is my new rough draft, so I'm just gonna go over this again. I have a stack and I'm going to be iterating through the tokens. If the token is an operator or operand, then I'm going to pop off the first 2 elements of the stack, calculate those 2 elements with that operand, and then push it back onto the stack. Now, if it's just a number, then I'll just convert that string into a number and push it on. Eventually, I'll reach the end, and after that, I just need to return the top of the stack. Because if the tokens that they give us is valid, then it should just, at the very end of all of this, it should only have one element left. Oh, come on. What? Oh, wait. Oh, okay. Oh yeah, oh yeah, oh yeah, oh yeah, oh yeah. Ah. Okay, cool. That was a really fun question. Hopefully you got a lot out of that, because that was actually one of my smoother mock interviews. The thing is, I sort of already saw this problem before, right, in one of my homework assignments, so that might have been kind of unfair and also kind of lucky on my part. Yeah, so that just goes to show that if you do a lot of problems, then you'll be really prepared and you'll be able to draw from previous problems and patterns in order to solve your current problem. What else should I say about that? So I guess I'm thinking, if I haven't seen this problem before, like in my homework assignment, how would I approach it? Well, first you'll have to know what the Polish notation thing is, and if you are able to understand that the rule is go to the first operand, then calculate the previous two, combine those together, then go to the next operand, take the previous two, combine them together, then I think, yeah, you'll be able to go to either the first solution I came up with was just do like a for loop or whatever, right, to find the operand, do the calculation, find the next operand, do the calculation, and also the stack. It's very helpful to just, if when you're stuck, it's kind of helpful to just list out all the data structures you know and go through each of them and ask yourself, can I use this in this situation? Can I use this in this situation? And it just so happens that the stack is very useful in this situation, in this type of problem. But yeah, thanks for watching. Let me know if you have any questions, if that was helpful. Any feedback is welcome. But until then, thanks again, and I'll see you next time.